Well, let's use power series to find an approximation of the natural log of 1.1, and let's try to find such an approximation with an error less than 10 to the minus 5. So we saw in the previous example that the natural log of 1 plus x for values of x between minus 1 and 1 is the sum from 0 to infinity of minus 1 to the n x to the n plus 1 over n plus 1. And now, of course, with x equals 0.1, we get the natural log of 1.1 is the sum from 0 to infinity of minus 1 to the n times 0.1 to the n plus 1 over n plus 1. So that's 0.1 minus 0.1 squared over 2 plus 0.1 cubed over 3 minus 0.1 to the 4 over 4, etc., etc. Now remember from our section on alternating series, we had a very nice way of controlling the error. We know that if we use the first m terms to approximate the sum, that the absolute value of the error is less than or equal to the absolute value of the m plus 1th term of the series. If I use the sum from 0 to 3 of this series to approximate the natural log of 1.1, that is, I use the first 4 terms, I get my approximation is 0.0953083, and this must have error less than or equal to the absolute value of the next term, which is 0.1 to the 5 over 5, which is certainly less than 10 to the minus 5. So this gives me a very close approximation to the natural log of 1.1. And of course, if I use only 3 terms, then I know that the error is less than 10 to the minus 4, but may not be less than 10 to the minus 5. Now you can actually use a computer to check the actual value, and the error in this case from using these first 4 terms to approximate turns out to be actually 1.8798 by 10 to the minus 6. So it's somewhat smaller than the upper bound for the error that I have, but that was to be expected.